Hi there, this is Aaron and welcome back. Now that we have basic understanding of what compensation is, let's look at what is platform dependency. Well, also do a short demo of platform dependency. Let's just consider a Windows machine and let's also assume we have written a C program called. To compile this program, we can use called tcc, and this would be the command tcc space hyphen or space hello space allowed c where allowed or c file containing the c program, while hyphen o is an option that tells compiler to name output file as hello, which will have extension in Windows. So on compiling hello.c, we get an executable file called hello.x, which include the machine code. Your compilation steps is also doing something calling linking. Generally, any software comprises of many source code file, and each source code file compiled into separate file called the object file, which has an extension dot or a dot object. Hello, for example, in this case, it could be hello dot r, and this object file or then group are linked to form a file executable file. This linking in many cases is done by compiler itself. However, it can also to be done manually by programmers themselves using another programmer called linker. In this example, compiler does the linking and thus generating executable called hello.x is finally executed by just typing in hello at the command line. Similarly, we can also compile the same C program on Linux machine using same command as on Windows, and this will also produce an executable. But in Linux, the executable will named hello dot. So extension is out here rather than X, which can be then rather executed by typing dot for forward slash. Hello, so what we have here is both executables being successfully executed on the machines on which those executables are generated. But this would not be possible. That is, hello executable generated on Windows machine cannot be executed on Linux, and that is examples of platform dependency. That is allowed X can be run only on a Windows operating system. To run it on Linux, we would have recompiled allow C program on Linux. Similarly, the hello executable generated on Linux cannot be executed on Windows machine. You would have to recompile on Windows, so the generated executable is specific to the operating system. So platform dependency is as to with operating system, and one main reason is to do the format of the executable file generated. It is due to the format file. Windows uses a format called P, which stands for portable executable, while Linux uses format called LF, which stands for executable and linker format. In case you are interested about this format, you read more about them on Google. Just search for portable executable or LF, and you can read more about them. Another reason for dependency on the operating system is when the program makes system calls. System calls are useful for performing operation like opening directory creation or even printing. To console or that terminal system calls are routed to the operating system kernel. Platform dependency can also be due to the hardware. For instance, machine code generated for program on An x86 processor would be different from the machine code generated for the same programmer on an ARM processor. So the machine on which executable is executed should be similar to the machine on which it is has generated. Otherwise, it has be recompiled using into appreciator compiler. So both operating system as well as hardware play a part of in platform dependency. Next, we will see how an interpreter can help resolve the platform dependency issue. But before doing that, let's just do quick demo platform dependency. So we are unable to run executable generated Linux on the Windows machine. So platform dependency. And next we will see interpreter helps resolve this. And Java, as we said earlier, is platform independent. So later we will share Java program and we also test platform independence. That's it. Thank you and see you in the next lecture.